Okay, quotient rule then. We've just done the product rule. Nice and easy. Just follow the formula. This is not much harder. So if you can do this one, you can definitely do the product rule. Basically, quotient is what you get when you divide something by something. So if y equals u divided by v, then the derivative of that is, you'll notice these are the other way around to what they were on the product rule. So it's v times du dx, and then it's got a minus sign in the middle. That's why they've been swapped round. Otherwise the minus sign will be out front. U times dv dx, all over v squared. So it's not hard, as you'll see. So for the example, let's do an easy one. 2x squared over sine x. You okay with that? You got that? So, let's do that in blue. So dy dx. So it's a case of just using the formula, working from left to right. That's all you got to do. So we've got, the top is going to be u, and the bottom will decide is v. It does matter, remember on the product rule I said it didn't really matter if you swap them around, but it does matter with this because whilst a times b is always the same as b times a divided by b is not the same as b divided by a, as you know. So it is important unless you start swapping the formula around. Why make work? Okay, so what we've got is v as it comes, so it's that big. Multiplying the derivative of the u, the top. So the derivative of that is 4x to the 1, yeah? Then we've got a minus sign. So you're just working left to right on your formula, on your rule actually. Now I've got u as it comes, the top. Times the derivative of v. So what's the derivative of sine x? Cos x, yeah. Nice and easy. No minus signs to worry about.
The divide the whole thing by.
That's it, all divided by v squared. So this is v. So this is
Cos x squared.
no, it's just v as it comes, but squared.
Oh.
So sine x. So squared. And as you're probably aware, there's another way of writing this, which is to write it like this.
Sin minus.
Have you seen it written like that before?
Yeah.
Yeah. Just to confuse you, really. It is confusing because if you see this, okay, following that rule, that means sine x times sine x. This does not mean 1 over sine x. Like that minus 1 does with your x's and things.
Is that a V or R?
That's a v.
Okay.
That is a v. So, I know this is not what we're doing today, but it's worth mentioning that that there does not mean that that's a crossing out plus sign. Okay? It's not the inverse of sine. That's the inverse of sine that you use in your calculator. This is the reciprocal, it's something else,
Find out angle.
which we will get to later on.
Isn't that to find out angle?
This one is to find out, yeah, it finds the angle from the ratio of your sides, the number you've got.
Trigonometry.
Yeah. Yes. We use it for waveforms in engineering. I mean, it does come in with triangles, obviously.
Any in the waveform.
No, it's to do with. If you've got a number like that, 1,
Yeah.
and you put it into the inverse, or actually it'd be pi, wouldn't it? Because it's with radians, it'd give you that value there. You get 1, you'd get pi divided by 2. Okay. If you've got minus 1, you would get 3 halves pi. It's 2 pi here.
And 1, then it's just pi in the middle.
Yeah, 0 would be any of these 3. You calculate to give you that one, but it can be any of them, infinite. So we tend to use it in waveforms. Okay, slightly gone off the subject a little bit. So you can see that's pretty easy to do. Sometimes you can tidy it up a little bit, make the formula, your result a bit tidier. but not really in this case. If you try splitting this up between the two terms, and you could cancel out one of the signs, but it's not making it any better. It's not making it any neater. It's not making it any easier to put in your calculator, which is what we really care about. What makes it easiest for us to use, or tidiest to look at. The only thing you might do is you'd bring this 4x to the front of here. If you were writing down a final formula that you wanted to go into print, you'd bring this to the front. Okay, so let's have a look at another one. A bit more trickier maybe. So y equals, let's say 2e 2x divide by, let's just go with cosine. Cosine 2x. Usually when you're working with the exponential and the cosine, you're usually using t as a variable, not x. Okay, right, so same principle. So I'll do it over here. It's not, so dy dx equals, just exactly the same steps, dead easy. Same formula, so v as it comes, this bit, and then you've got times the derivative of the top. So what's the derivative of 2e 2x? What's the derivative of this? 2e 2x.
4e to x.
Right, cool. There's stuff at the top, stuff that would
Oh,
be
that stays the same.
stays the same, yeah. Okay.
In the exam, would it come in brackets or will it be like that?
Yeah, strictly speaking, it should really be in brackets, but because it's clear what it looks like with it all being lowercase letters, not lowercase, smaller size, but you know, floating in the air. It's usually obvious. If you cast your calculator, we'll put it in brackets though, like that. It's because you don't have a situation where you would have, if it was 2 plus x, you don't have a situation where you would go e to the 2 and then add x to it because it's in the power position, so you know it belongs to the 2 and the x belong together. So it's not as confusing. So minus sign next, and then we've got the u as it comes, so that's that bit. Nothing done to it. Times the derivative of cosine 2x, which is derivative of cosine 2x.
Minus 2.
And what do I need to do because it's got a minus sign?
Times brackets it.
Bracket it, yeah, so it's clear it's multiplying it, not subtracting. 2 out front, sine 2x, those brackets. All divide by cosine 2x. And we'll do it that style. Okay? Everybody comfortable with that? There's nothing too tricky there, is there?
Yeah, a bit.
Good?
We'll do another one.
Yeah, sure. Certainly. Let me rub these off. I'll start at the top though.
Not to the bottom one yet.
I'll leave that on. Yeah.
Yeah, can I just
It's that you have to think of some. So I know one that's a bit of a challenge. And which I'll put on the bottom. Let's tell you what I'll put. X plus 2. A bit more of a challenge. So U and V as before. Can I rub this off now?
let me just take a picture of it.
Okay.
Are we doing that top?
Okay. Right.
Yep.
Right. So same again. dy dx. So go slowly if it's confusing with this log of x and the like. Let's go, let's see. So we've got, this is u, this is v, so we've got v as it comes. So because it's got a plus in the middle and it's going to multiply the next term, you have to keep it in brackets. And then it's times the derivative of the top. So what's the derivative of log of x?
1 over x.
1 over x. So it's the same as before. You can either write it like this, or
Just put the whole thing over it.
just put the whole x underneath like that. It means exactly the same. And that's a neater way of doing it. Minus, so u as it comes, the top, and then it's times the derivative of the bottom. So what's the derivative of x plus 2?
X squared.
What was that? Yeah, well, because there's you only bit. This is a constant. So we're going to apply the sum rule to that bit in the bracket now. So the x is a 1.
So it's just x.
X, yeah.
So it's and then there's nothing for that yet. So it's times 1. So it stays the same in actual fact.
So just x plus 2.
So you put it down to start with, and then you can, when you tidy it up, you just ignore it. You don't have to put it down. It's up to you. It just means anything times 1 is the same. Stays the same. Right, now the whole lot.
And then over x plus 2 squared.
Yeah. Now do I put it on the same level as this one, or do I put it like that?
The whole thing?
Yeah. It's easy to trip up on that. So it's x plus 2 squared, which of course you could multiply out into a quadratic if you wanted to. If you wanted to make a nice tidy equation to write in, to keep say it was a solution to a problem you're going to keep using, you tidy it up for sure.